Imagine a world where your thoughts aren't confined to your skull, where you could interact with technology, communicate, or even move a robotic arm just by thinking it. Sounds like science fiction, right? Well, brace yourselves, because that world is rapidly becoming reality. Welcome to Sciencepect, where we explore the cutting edge of science, technology, and space. Today, we're diving into one of the most revolutionary fields out there: brain-computer interfaces, or BCIs. This isn't just about cool gadgets. It's about fundamentally changing how humans interact with the world around them, and potentially even augmenting our own abilities. We'll explore how these interfaces work. See the incredible impact they're having right now on people's lives? Look at ambitious projects like Neuralink, peek into the mind-bending future, and critically discuss the vital ethical questions this technology raises. So what exactly is a brain-computer interface? At its core, a BCI is a system that allows direct communication between the brain and an external device, like a computer or a prosthetic limb. It bypasses the body's normal pathways like nerves and muscles. Think of it like this. When you decide to pick up a cup, your brain sends electrical signals down your spinal cord, through nerves, to your arm muscles, telling them to contract. A BCI intercepts or interprets those brain signals directly. There are different ways to listen to the brain. Non-invasive BC is like those using IG caps on the scalp. They're the easiest to set up, but get a less clear signal because the skull and skin act as filters. Partially invasive methods like ECOG, where electrodes sit on the brain's surface, offer better resolution. And then there are invasive BC, is where tiny electrodes are implanted directly into the brain tissue. These provide the richest data, but involve surgery. The system works by recording your neural activity, basically the electrical chatter of your brain cells, then using complex algorithms and machine learning to decode those patterns into commands that a computer or device can understand and execute. It's like teaching a computer to speak the language of your thoughts. While the futuristic visions are exciting, the most profound impact of BCIs today is in the medical field, particularly for individuals with severe paralysis caused by conditions like spinal cord injuries, ALS, or stroke. Imagine being unable to move your limbs or even speak, but still having a sharp, active mind. BCIs offer a lifeline, restoring a degree of independence in communication. Pioneers in this field have developed systems that allow patients to move robotic arms, control computer cursors, type out messages, letter by letter, and even operate wheelchairs, all using just their thoughts. Projects like BrainGate have shown incredible success, enabling people who were completely locked in to communicate again or manipulate objects in their environment. It's not just about regaining physical function, it's about restoring agency and connection to the world. Beyond motor control, researchers are exploring BCIs for treating conditions like epilepsy, depression, and even chronic pain by using them to monitor or stimulate specific brain areas. This is science directly improving lives. Now, when most people hear about brain-computer interfaces today, one name often comes up: Neuralink. Founded by Elon Musk, Neuralink is one of the most prominent and ambitious players in this space, though certainly not the only one. Neuralink's stated goal is to create a high-bandwidth, minimally invasive brain implant capable of reading vast amounts of neural information. Their device, the Link, involves thousands of tiny, flexible threads, thinner than a human hair, implanted into the brain tissue by a sophisticated robotic surgeon. Why high bandwidth? They believe that to truly understand and interact with the brain, you need to listen to many neurons simultaneously. Their initial focus, like many BCI companies, is on medical applications, aiming to treat severe neurological conditions such as paralysis, blindness, deafness, and brain injuries. Recently, Neuralink announced a significant step: the successful implantation of their first device in a human participant. This marks a critical milestone, moving from animal studies to human clinical trials. The data gathered from these trials will be crucial in understanding the safety and efficacy of their system in humans. It's important to note that while Neuralink is high profile, other companies and research labs are also making significant progress with different approaches. Current medical applications are impressive. The future possibilities of BCI technology venture into territory that feels truly science fictional. Imagine human augmentation, Could BCIs enhance memory, boost cognitive function, or even allow for direct brain-to-brain communication? The potential to expand human capability beyond our biological limits is one of the most exciting and perhaps daunting prospects. Think about virtual and augmented reality. Instead of clumsy controllers, you could interact with digital worlds seamlessly, just by thinking. Games, training simulations, collaborative design, all could be controlled with unprecedented speed and intuition. BCs could also unlock new forms of artistic expression, or provide entirely new sensory experiences. The line between human thought and digital interaction could blur, opening up possibilities we can barely conceive of today. However, as we venture into this future, we must confront the serious ethical implications. Accessing and interpreting brain activity raises profound questions. Privacy. How do we protect our most intimate data, our thoughts and feelings, from being accessed, used, or even sold? What safeguards are needed to prevent surveillance or manipulation? Security. Could brain implants or BCI data streams be hacked? The potential consequences of unauthorized access to our minds are chilling. Equity. Who will have access to these potentially life-changing or even augmenting technologies? Will they exacerbate existing societal divides, creating a neurologically enhanced elite? Identity and autonomy. If technology can directly influence our thoughts or moods, what happens to our sense of self and free will? These aren't easy questions, and they require careful consideration, regulation, and public discussion as the technology develops. It's crucial that the development of BCs is guided by strong ethical frameworks. So there you have it. It's from restoring movement and communication for those in need, to the ambitious goals of Neuralink and the mind-bending potential for human augmentation and seamless digital interaction. Brain-computer interfaces are at the forefront of technological evolution. This is a field moving at lightning speed, promising incredible benefits, but also demanding careful ethical navigation. The journey from controlling a cursor with your mind to potentially enhancing human cognition is not just a technological one, but one that touches on the very essence of what it means to be human. What are your thoughts on BCs? Exciting, scary, or a bit of both? Let us know in the comments below. If you're fascinated by the future of science and technology, make sure you're subscribed to Sciencepect. We'll keep exploring these groundbreaking topics together. Hit that subscribe button and the notification bell so you don't miss our next deep dive. You can subscribe right here. And check out our playlists for more on science, tech, and space. Thanks for watching. See you in the next video.